In this video, I am going to explain about jump instructions. Jump instructions are used to change the program sequence. It is similar to if statement in C language. Let's see the types of decision opcodes. We will be discussing in this jump and call instructions, that is jump on bit conditions, compare bytes and jump if not equal. We will be discussing decrement byte and jump if not 0, jump unconditionally, call a subroutine, return from a subroutine. Let's start with the jump instructions. Jump instructions are of two types. One is the conditional jump instructions and the second one is unconditional jump instructions. Coming to the conditional jump instructions. Conditional jump instructions means jump to a label when a condition occurs. Okay, if you see the syntax here, okay, let's see about conditional jump instructions. But before that, we have two types of conditional jump instructions. One is byte conditional jump instructions and other one is bit conditional jump instructions. Okay, so this is a jump and call program range. The relative range is minus 128 to plus 127, absolute short range and absolute long range. Let's discuss all this in the next coming slides. Okay, now let's start with bit conditional jump instructions. Before discussing about the bit conditional jump instructions, let us talk what is a conditional jump instructions. Conditional jump instructions means jump to a label when condition occurs. Okay, the syntax says that we need to write an opcode and then we will be writing a label name. Okay, it has to jump to some address location and it has to execute the instructions which are present in that address location. So for that purpose, the syntax says that we need to write an opcode or a mnemonic. The mnemonic for the jump instruction is JMP, is a mnemonic for jump, and then we will be writing as a label name. Okay, we will be writing the address locations. So instead of writing the addresses on the paper for the identification purpose, we write the label names. Okay, instead of writing 2000 as the address location, instead of writing 2000, I'll be writing some label name. It can be anything, is, was, and the, any label name you have to write, and it is going to execute the instructions whatever is present in that particular label name. Label name is nothing but the address location. Okay, so the syntax says that opcode or a mnemonic, that is JMP, followed with the label name. Okay, now whenever you can see that if you go with the bit conditional jump instructions, we will be having the mnemonics related to the bit conditional, but everything follows with J. Okay, that is jump, and this is your label name. The label name talks about the address. Okay, it has to go to that address and it has to execute the instructions present at that particular address location. Okay, so if you see here, the instruction is conditional jump instruction. So during the execution of the instruction, program control checks the specified condition. If the condition is true, then the program control transfers to the specified address and executes the instructions from that memory location. If the condition is false, the program controls executes the next instructions of jump. Okay, so what does it is saying is, it means that what it is going to check the condition here. If the condition is true, then it is going to move to this address. So whatever the content is there in this address location, it is going to execute the instructions. Suppose in some cases the condition may be false, it is going to check some condition based on this mnemonic. Okay, if the condition is false, then what happens? It is not going to go to this label, it is not going to move to that particular address location. The program control, what does it do? It doesn't move to this address location. It executes the next instructions whatever is written after this instruction. Okay, that is about the main thing. This is about the conditional jump. Now if you go with the unconditional jump generally, what does unconditional jump means? That jump to a label without any condition checking. Means it is not going to check any condition, simply jump. Now if you see the syntax again, we have the mnemonic as a JMP and we'll be having a label name. So here it is going to not check the condition at all. Here we don't have any condition checking in unconditional jump. Normally we will be having a mnemonic, so it is going to execute this. Okay, it is not checking any condition here. Directly it goes to this address location and whatever the instructions are present at that particular address location, it executes it. Okay, so unconditionally it will be jumping, means jump to a label without any condition checking. That we call it as unconditional jump instructions. Okay, now let's start with, as we have already seen, Conditional jump instructions are of two types. One is bit conditional jump instructions and the second one is byte conditional jump instructions. Let's talk about bit conditional jump instructions. Okay, before talking about bit conditional jump instructions, a small note here. All the 8051 instructions are not single byte instructions. Some of the instructions in 8051 are 1 byte, 2 byte, 3 byte and so on. Suppose if it is 1 byte instruction means then it requires 1 byte of memory space. Suppose if it is 3 byte instructions means it requires 3 byte of memory space. Okay, now if you take this example, okay, we have a jump with carry relative address. Now what happens here when you have like this instruction is going to carry 2 bytes. Okay, if you go with this one, this instruction is going to carry 2 bytes. For this one 1 byte and for this one 1 byte. So this instruction is going to carry 2 bytes. If you go with this instruction is going to carry 3 bytes, 1 byte and 1 byte. Coming to this instruction, it is going to carry 3 bytes, 1 byte and 1 byte. What about the fifth instruction? Even this instruction carries 3 bytes, 1 byte and 1 byte. Okay, so here all the 8051 instructions are not single byte instructions. Based on the instructions, some can be 1 byte, some can be 2 bytes, some can be 3 byte and so on. Okay, now coming to the relative address. What is R address here? R address is nothing but relative address. It is an 8-bit address. Okay, where it is going to range from -128D to +127. Okay, so now let's start with the first one. Before starting with the first one, just we will be having an overview of instruction cycle where you have studied in CO. In the instruction cycle, we will be having 3 phases: fetch phase, decode phase and execute phase. So what happens in the fetch phase? During the fetch phase, the program control reads the instructions from the memory and places that instructions in one of its CPU registers, and after that only it increments the PC value by 1 or 2 based on the size of the instruction. Okay, if the size of the instruction is 1 byte means the PC value increments by 1. If the size of the instruction is 2 bytes means the PC value increments by 2. So finally the program counter value is going to get updated so that the PC holds the address of the next instruction. Okay, which is going to happening in your fetch phase. Coming to the decode phase, the program control decodes the instruction. After decoding the instruction only, the processor knows what operation it has to perform for executing the instruction. Coming to the third phase, we have execution phase. In execution phase, the processor performs arithmetic, logic and shift operations necessary for executing the instruction. So finally, we will be having the PC value in the fetch phase. In the decode phase, it is going to decode the instruction, and in the execute phase, the processor is going to perform the arithmetic and logical and shift operations necessary for executing the instruction. This is what we have seen in the instruction cycle. Now now let us go with the bit operations. Now let us see the first instruction what we have in the bit. We have a mnemonic called JC, where JC stands for jump if carry is set. Jump if carry is set, and then we will be having this as a label name, that is R address, that is relative address. Okay, now what is this operation says that jump relative if the carry flag is set to 1. So what it is doing is we are talking about the bit conditional jump instructions. So if you see, all the instructions will be having only a single bit. Okay, so here the carry flag is going to have either 0 or 1. So it is a single bit. So here the condition is if C equal to 1. I said that C equal to 1. That is true generally. Jump if carry is set means carry is equal to 1. The meaning of JC stands for jump relative if the carry flag is set to 1. What does it meaning? Says that JC is C equal to 1. Okay, whenever this condition is true, then what happens? We already seen that whenever this condition is true, the program control, what it is going to do, it is going to move to this particular address and executes the instructions from that memory location. Generally, if the condition is false in some cases, before this instruction you will be having some case where the carry flag is equal to 0. Okay, now we are getting the carry flag is 0. Whenever we are getting the carry flag is 0, the program control doesn't move to this address. Generally, it executes the next instruction in sequence. Only whenever the condition is true, what the program control is doing, it is going to move to this address and executes the instructions from that memory location. That is about JC. Okay. Here you will be having a description. That description I'll be explaining when I'm taking the online sessions to you. Okay, remember that the first instruction is JCR address. It means jump relative if carry flag is set to 1. The second instruction is JNC relative address. It means jump if no carry, means carry equal to 0. Whenever that condition happens, then it moves to that address. In the next video, I'll be explaining each and every instruction clearly. Thank you.